problems. Got our 10 kilogram box still, and we're going to do a friction problem here. We have a bunch of forces acting on it, going clockwise from the left. We have a 30 to the left, a 20 up, a 50 down, a 100 at 30 degrees, kind of like if you're pulling your wagon, and 60 to the right. I left out newtons just to make this a little cleaner, and I'm hoping you're starting to recognize my handwriting and decipher it. What we've been asked to find is part A, if it moves, question mark, and assuming it does, part B would be find the acceleration in the x direction. Obviously if it doesn't move, that makes part B equal to 0. And we're given that the coefficients of friction for static and kinetic are given right here. So that's how we know there is friction. Alright, the first thing we always want to do whenever we have this kind of thing with forces, we want to try to clean it up and find out the net forces. So we're going to have mg down. We're going to have F of n up because it's on the ground. Horizontally, we have a 30 to the left and 60 to the right. That comes into a 30 net. Alright, if I pull 60 this way and 30 that way, I come up with 30. So I get rid of those two. Up, I have a 20 up, 50 down. That gives me a net of 30 down. So it takes care of those two. And then the last thing I have to deal with is this 100 acting at 30 degrees. So we want to deal with that one. Again, we use sine and cosine to break that into x and y components. 100 cosine of 30 is going to give us 86.6, and 100 sine of 30 will make this a 50 up. Alright, so this right here turns into these two right here. We break into components. Now, since we have friction acting, I'm going to put friction there. I'll make it red. Hopefully that shows up on your monitor. And we have friction because it's obvious pulling to the right, nothing pulling to the left, that this is going to try to move this way. We expect the motion to be that way, so friction will act opposite. Now, again, with friction problems, we always have to start out with summing the forces in the y direction to find F of n, because F of n goes into the fun equation, friction equation. So, summing forces up, we're going to have, let's see, the minus 30, the plus 50, the plus F of n, minus mg, that has to all equal 0. That takes care of 1, 2, 3, 4. Tells us that F of n is going to equal mg. Minus 20, I think, is what that comes out to be. 10 kilogram box, that's 10 times 9.8 gives us 98. Minus 20, that means its F of n is 78 newtons. If F of n is 78 newtons, then we can go and find out that the force of friction statically is from the fun equation. That's going to equal, equals 0.8 times 78. And if I had somebody here with a calculator, that would tell me that's somewhere around 60, about 62 newtons. Alright? That tells me how much friction is going to pull back. So this becomes a 62 that way. Alright, step 3, I'm going to look in the x direction and sum forces. Now, if we look at this, 86 and 30 is 116 to the right. Friction only pulls back with 62. It is definitely going to move. If it's going to move, we have to switch over and look at the coefficient of friction, or friction in the kinetic. So I have to get rid of that and actually put in 0.4. That's going to cut that in half to 31. So really, since we know it slides, because this was greater than the 62, we have to use kinetic, and since it is moving, we're going to use Newton's second law. F equals ma. That's going to be the 86 plus the 30 minus 31 for friction equals the 10 times ax. So if it does move, we say yes, and this ax becomes 8.7, I believe, meters per second squared to the right. And that's, again, running up against that 5-minute limit. I apologize, but that gives you a quick problem on solving those.